Good evening, everyone. So, yeah, let me know when you are able to see my screen.
Yeah, I can see.
Yeah. Yeah. So it is that like we can start right
I
from
can see.
the image itself. I think you can see as one image where it is having a curve and it is showing some sort of earthworks and stuff. So I just wanted to know, since you from different backgrounds, because software is just a thing when you combine with the technical knowledge only, theoretical concepts only, we can understand in a better way. So that is
True.
why I just kept these terminologies here. So if you are if somewhere if you are not comfortable with the terminology as well, maybe those at least in brief we can touch it, like the transition length and superposition and camber, those kind of stuffs. So yeah, so I just wanted to show you the workflow, as I said, how the projects actually goes, right from the design consultants. And once it is done, it just generally hand over to the contractors. Once it is done, generally while it is being done, there are a supervision consultants who look after the works. Once everything is done, when we hand over the executed work to the client, then there will be O&M consultants, which are called operation and like and maintenance consultants. So what they does, they just look after the work. So when you see, this is a very long, a lengthy process and out of a project life cycle. In there, we are as a designers, we generally involve in the design consultant stage, or sometimes even the contractors also engage consultants to design the projects. So we are involved in here. Even when you dig into the design consultants tasks, because there might be before you directly get into that, there might be many surveys they generally take care. So I've just mentioned a few surveys just to give you briefly, and just to make you highlight where it actually stays. When you see, these are generally any project, any road project, these are the surveys in any country, irrespective of the country, I can say, because the terminology might be different here and there, with respect to the like Middle East, or the European countries or Nordic countries, in India even, I can say. So it is just only that the topographical survey starts with, and the traffic surveys, and the road inventory and condition survey, and the rest of. And the reason why I highlighted only these three, these are much relevant to a highway designer, a geometric designer who designs alignment and looks for the constraints. Now, one of you as mentioned, like they just wanted to design alignments, and they wanted to keep the constraints in their mind. So this is where we actually need to concern about. From the topographic survey, it is that we get a xyz of an existing ground. Let us say you have a existing road, and when you want to widen it, when you want to widen it from 2 lane to 4 lane, let us say. So obviously, in order to develop that design, and the software, we need to have a reference of existing surface, for which a topographic survey is done. In these days, we generally do a manual survey with and sometimes we do a lidar, and sometimes we do even aerial survey to get the ground elevations. When I say elevation, it is x, y, z, and the coordinates, and along with the elevation of each and every point, that we can see detailedly when we get into the software, how data comes and all. And the reason why I highlighted the traffic surveys, one or other way, it is indirectly or directly, it is relevant to the geometric design, because based on the analysis that they take care, they did, they tell you what is the lane capacity need to be done, and to what lane configuration the route has to be designed. So that is where we just get it. And from these things, even they do payment analysis and payment design, where you get the payment layer thickness details, which you need to incorporate while you're doing the geometric design. And this is one of the thing, the name itself is saying that inventory and the condition. When you say inventory, you are doing inventory for the existing road. So what is the condition, what are the elements, and as one of you said, what are the constraints, whether it is a urban area it is passing, or do we have any forest or eco sensitive zones or religious structures which we can't demolish right away. So those are kind of constraints are noted. And the condition, how the payment condition is there, does it has to be like overlay is required, or does it have be reconstruction is required, some sort of those things were covered in field survey investigations. And I'm not getting into the other things, but these are also somehow or other way they fall in place. during the field survey investigations. Now let us see the analysis. Now you have collected some data here, and I'll just show you what analysis are generally taken place. So as we collected traffic data, the traffic analysis is done. As I told you, we'll get the information what lane configuration is required, and in the payment design we'll get to know what is the payment thickness layers like surface course and sub base and base and subgrade. So those details we'll get from the payment design. And of course, once geometric design, that is where we actually design our how the alignment should go and what design speed it is and what is the radius to be provided. And if the slope elevation is there, how do we need to rotate it? If we have any cross drainage structures, let us say you are crossing a stream, so how do you need to put your alignment? So it is all comes under geometric design. And the drainage design, obviously, so based on the topo data you are having, like it is a one of the analysis. Again, they do the drainage design, and sometimes it has to be interlinked with the geometric design outputs. So that is one thing. And the structure design, obviously they do the structures, cross drainage structures. And apart from those, like obviously in any project, if you see in terms of highways or anything, so obviously ultimately you need to have the quantity estimation. Based on that, they check the economic and financial analysis, where they check the financial viability of the project, whether the project can go forward or not. And certainly we will submit the drawings to the client. This is a general flow of any field surveys and the analysis and design. Now once we get into the geometric design, there is a default flow, I can say. Let it be of any software you concern about, or you might learn in the future, but this is the only flow that it goes. So it is all about, you did your topo survey initially during the field survey, so you collected the data. So that is where you need to make some surface. I'll tell you what the surface is in the when I start the civil 3D one. So but just get familiar with this existing ground preparation, you can even say. So you made a surface, and then you started designing your geometric horizontal and vertical design, where you see the constraints horizontally, vertically, and you designed it. And then you develop your roads, carriageway edges, and the earthwork lines and everything. Then you extract the earthworks, and finally you submit the drawings. This is the flow irrespective of the software. So and when it comes to the course now, so now we have seen we seen that how the workflow is out of the design consultant responsibility and the response, the service they took. And out of that, you have a geometric design, one such small element, but even though it is a very important and vital one. um, so just to take care of that, so this is the course content briefly that we cover in our entire course. The reason why I highlighted here the red, these things here, if you see the data import and the creating surface, that is when you see here, this is what it talks about. This element is covered there in data import and creating surface. And I have highlighted here like assembly coordinates, population, sample and cross section, quantity takeoff. These are all covering your entire these things. So let it be, any software will have the same flow, but the only thing is that the terminology will change from the software to software. So, and I'm not in that kind of person where I only talk in terms of only the software. I just wanted to tell you anything with respect to the actual practical cases, so that I thought that that would make you to understand the importance of the software. So yeah, that's all we are going to cover it. So today I'm not willing to start dive into entire civil 3D or something. So this is how we start, and let us only just get into the basics of the civil 3D, what it is and what the tools and all. um I've just kept here one slide here just to show you how it looks here. So again, when we get into the civil 3D, you can see it there, but there are three windows it generally get separated. One is a ribbon, and one is a drawing area, and sometimes it is called as a model space as well. And you have a prospector, a tool space, where everything within the civil 3D that you can organizedly you can see it here. And since some of you are already familiar with AutoCAD, generally when in the AutoCAD, what happens if you have any point, just that's it, that is a point until you select it and you see the properties of it, but you can't able to organizedly you can't see it. In civil 3D, that will be under the category of points. It, the data segregation is much better, and the way how you analyze in Civil 3D is much better and dynamic. So if I get into the Civil 3D, the same thing that I've shown you here, this is actually called the tool space. That initially when we open Civil 3D, it will be something like this. So if you click on this one, tool space, it is something like this, where you have all such elements. Like no need to worry, like when once we start getting in one by one, you will understand what the surface is, what the alignments is and everything. So but as of now, just you can see it is a tool space which is very it used to data segregation. Whichever you keep, whichever the data you keep here in the model space, that data can be segregated in the tool space. That you can remember as for now. And this is all about a ribbon, where if you see the home, it has some content about the points. It says, when I say points, you can interlink this with the survey data. So generally the survey, when you do the manual survey on the site, you have the x, y, and y, z. Even in in the same way, every point will have a x, y, z. In the same way, when you see here create design tool, in this pan you have alignment, profile, corridor, intersections, assembly. So there are, these are the tools which we frequently use to make our alignment or geometric designs. And this is where we, if you see these ones, to represent the cross sections and the profiles. Um, and about like that, this is our home. And in the same way, you have certain toolbars just followed by that. So when it comes to insert, when you want to insert a data from an external file, so this is where you use the insert. Like if you have a point data in a file, you can import it directly from here. And if you have the annotate tab, it is all about how you represent the data. I'm like, I'm trying to give only the brief now. So when you get into each and everything, then we better understood how each one will be useful. It is just only that, let us say you have only you have a point here, and it should have a text. How do you represent the elevation of it? So for those elements, that the add labels will be useful. And the modify, it is that you have made some alignments and some designs, and you have something on your model space to give some edits. So the modify will be useful. And when it comes to analyze, so this will be useful for you. You did your entire design, and you want to check your earthworks, how the cut and how the fill is coming, how do you compare them? And to analyze, and like when somebody asks you what is the side distance is achieved in your particular road that is being designed. So at least, and those sort of analysis, the analyze will be useful. As you can see, it is having visibility check and those things, as I said, analyze. So like that, you are having many things. Like it is about view frames and the viewport and the configurations. It is the manage is all about data shortcuts, which is very one of the very much important term in the Civil 3D called data shortcuts. We'll get into the detail later. So and the output, so it is just only that if you want to export the data what you did. So there are number of ways to export the data from Civil 3D, so which you can do it from the output tab. So it is all something relevant to those elements. Like survey, it is how do you segregate the survey data. And it is all about rail elements, as we do uh, highway elements. In the same way, we can do even the rail engineers can also use this software, Civil 3D. And there are certain commands which are called transparent commands. Sometimes those are also usable when you have a particular data to design and stuff. And the InfraWorks, you might have heard about the name called InfraWorks. It is a visualization software. It is also Autodesk product. That is why it has been added in here. So the data exchange will be much easier between the Civil 3D and InfraWorks. You might have seen, generally you might seen there will be 3D models like almost everywhere it is floating around nowadays. They generally be done in InfraWorks. You design everything in Civil 3D, and you get the data exported to InfraWorks, and you open it there, and visually you can make it better in InfraWorks. It is not a design software, InfraWorks. It is just visualization software. So yeah, so those are all the things. Like it is very much a required one in the Civil 3D, which we continuously use it one. So this is all comes under ribbon. And if you get on to the start button here, so whenever you want to start with a new file, you generally this is where when you click on it, you can start with a new drawing. And when you want to, you have already file in your local file, and when you want to open it, you can open it from here. And it is just for save and save as. Like when you wanted to save as in other formats, you can save, like you have a drawing file, and if you want to save it as a dxf, which is a format which is used for the mx roads input. So like that, you can export, you can save it as for the other formats as well. And it is export similar to the output tab, whatever we have seen there, it is similar to that export only. So it is of that sort. You can export to different different versions of the
Rajesh,
files. So it is just that I'm just explaining the each and the options, how we generally use and where do we use this. So when you want to open a when you want to start a new drawing, so we generally click on the new and we just start right away on the drawing, whatever we plan to do. And if you have a drawing already existing in your local system, and if you want to open it, so you'll open it from the open. When you click open, it will relocate to the folder so that you can browse it and you can open it. And the save, if you want to save the current file, that whatever you work, you can do it from here, or otherwise you can do control s. And the save as, if you want to save as to other formats, not only the dwg, you can even, there are many formats like dwt, dws and dxf. So some other, there are other formats as well, so which you can save it when you are doing save as. And when it comes to export, let us say you design something which is with you, and since here I think some of you are familiar with the AutoCAD. So generally what they do, once a designer did something, in order to put them in the viewports and to print on the paper and to submit to the client, obviously the civil 3D files are generally exported as a AutoCAD drawing, and they will be giving it to the CAD technicians, to draftsmen, to put it in the actual layout system, and they work on some legends and everything, and they make it on the paper. So in order to give it to them, so generally we use the export frequently, very much frequently, either to use it as a dwg format, export as a civil 3D drawing, or sometimes if it is required, even we deliver in the other formats as well. So, and the publish, you can just, we can do it is just a 3D solid you can do. And sometimes you have so many extras too, and which you can't share every extra file with the others, so that you can use the e-transmit as a published thing, and those things it is for. And print, that we know it is just to make it as a pdf, if we want to see how was the drawing is looking like, and just in those cases we use the print and those things. And there is a one more interesting thing is that if you have a, let us say you have submitted a drawing, and the same drawing the client has sent with the comments, and then you can use this drawing compare option to see actually what are the differences, because it is hard to find out manually what comments they have given and kind of stuff. So this, that is where it can be used much. The close, you can right away close the file. Either you can, if you have the multiple tabs open, you can close the only the current file, or you can close the all files together. So yeah, it is something all about that. And when you see this tab here, it is all about the recent files, whatever you open, so those will be shown here. And let us say you have opened 10 files, because it has some limit. After that, obviously the last file will get deleted, and the deleted means it will be disappear from this window, and the recent one comes up. Let us say if you are working in a same file unfrequently, and if you don't want get to be go down, or if you don't want get to be disappear, then you can pin that thing here, so that even if you open 20 files, the other list of files might get disappear, but the file that you pin will be shown on your top only. So that is one thing about this. So that is all about a very brief thing about the ribbons and the start thing and the model space. And when you come to tool space, as I said, which is a very much essential and important one in civil 3D. So if you see in the tool space, this is the tool space, the tool space under which you have certain tabs, again divided tabs, which is of like prospector, settings, survey, and toolbox. So you have a prospector now, which when you get into the prospector, you have a certain elements, points, point groups, surfaces, alignments, feature lengths. So these are all terminology which are generally can read by civil 3D. The software can read these terminologies. And the best part in Civil 3D, let us say you have made an element, something like this. So when you give generally when you see in the properties, now it is showing as a polyline. Let us say it is now, just to make you understand, I'm just making a rough one element. Now I'm not getting into the details because we can get into the details of the alignments when we actually get into the that part. So just to show you how this works here. So now you are having an element. When you select it and when you see the properties of it, you can see the properties from here. When you select it, um, either you can do control one or you can go to home, and this is a properties one. So here if you see, it is showing the this property as a alignment. And the interesting part in the Civil 3D, that Civil 3D prospector tab will identify whatever there in the model space and which category it is falling under, and it will just push into that category. If you see earlier, I'll just delete this now. Then you can observe that this amru description, whatever the alignment name, will get disappear there. I'm just deleting it from here. So the moment when I deleted, it got deleted from this window, which means it is able to identify it as a alignment, since you have given the property as alignment. So if it is a feature line, accordingly that will be pushed under the feature line. So if it is a corridor, that will be pushed under the corridor. So I like it, even if you're not familiar with what that feature line terminology and the word corridor terminology, that will get into the thing. As of now, that you can consider that any property or any object within the Civil 3D, if it is defined by some property, either as an alignment, either as a profile, either as a corridor, either as a feature line, if you define it, then that will be pushed under that particular element of the prospector tab. So that is one of the best things, so that it is the way the how the work goes in Civil 3D is like in an organized way. So yeah, you have, and when you observe it, here you are having certain types of alignments. Generally when somebody asks you like highway alignment, they just only say highway alignment. But when you see here, under the alignments there are certain types: center line, offset, curb returns, rail alignments, and miscellaneous alignments. So we'll get into the detail when we see actually what elements need to be as center lines, and what to be as called as a offset, and what to be called as a curb return elements. um, and when you, as I told you earlier, here when we are talking about manage, I've told you about this is a very much interesting and important one in the data show, which is called data shortcuts. The same thing is showing here as well. So I just wanted to tell you the importance of it. It is just, let us say you have you are doing a road project or any aerial development project or any big infrastructure project of, let us say, 10 by 10 kilometers section, which is a very big one obviously. So when you do a survey, uh, when I say survey, which means that you will have x and y. Let us say they are collecting a point, something like this. So this point will have a x and y and z of data. I just wanted to show you here. So this is how a topo survey is collected on existing roads today. So they, what they do, they take the existing center line and the existing carriageway edges, and if the shoulder is there, and I'm assuming that you are all familiar with the cross sectional elements of the road. When I say cross section elements, those are like carriageways and shoulders and the embankments, those elements. So that's how they collect it, and depending on the project importance, they collect the data at every 50-meter interval across the road. So when I'm selecting this point here, and when I see the properties of it, here you can see it. This is what it when I said x y z, this is what the positions, northing, easting, and the elevation of that particular point on the ground. It will, the surveyor will take it and they'll record it in the system. So this is how, like, sometimes we get the data in like this, and sometimes we get only the point data. When I say point, you just only have the elevation. You do not have these lines. So even sometimes we even get that as well. We'll see in the next classes while we are talking about surfaces, how do we make surface and what is surface mean by, and those stuff. And I'm just again going to the again. So let us say now you are like the way that we have seen survey data. Let us assume we have collected the data for 10 kilometer length and 10 kilometer width. That is a area development plan. Let us assume there is a big a city is coming, and so they wanted to develop everything, let it be roads, drainage, buildings, and everything. So when you have that much big data, obviously that the data cannot be handled by civil 3D. Where if you let us assume you have a surface here, and if you plan to make your alignments, so if you want to plan, if you try to make your alignment something like this, and in the same way if you plan to make your corridors, which is of, when I say corridor, it is just a carriageways. So so keeping all data in one single file, it is very hard for civil 3D to handle it. So that is why the recommended process of the design is always, you need to keep your surface in one file, in one file, and in order to make your alignments and the corridor design in one file. So now when I say like you might be having one question that okay, you have your surface here and you are having your actual design here, but how do you get the data to this surface? So that is where the data shortcut is useful. What it does, you can link this file surface to this file, so that whichever file you use, you can use the surface and you can proceed with your design. So that is how the data shortcut is very much needed and very much necessary in handling bigger data. So it is not just only for surfaces. You can create the data shortcut for alignments and the corridors and etc. So yeah, that is one of the important part of the data shortcuts. So that is how the data is segregated in the prospector tab. And when you see the other tab here, settings, it is showing that it is having several the same element. If you closely observe it, points, surfaces, alignments, and the corridors and the assemblies. And when you see the settings tab as well, you have the same sort of data, points, surface, alignments, and profiles and everything. So it is just only that the settings tab is only useful. How do you represent the data? Let us say you might have even though you haven't designed earlier, but you might have seen earlier in any way, in a hard copy or in somewhere, center line elements might be seen in red color, or carriageway might be seen in white color, or the contours might be representing in the different colors. So it is just a way of representing. How you represent it, it is a style. It's a style of the particular object, civil 3D object. Roughly if I want to show you now, I'm just drawing one rough alignment just to show you how it looks. See, so here what is happening, um, when you see the alignment is designed or represented in the red color. So which means that there is some style set here which shows that alignment should shown in that color only. So it is all about style sets. So that we it is not just only dictating the alignment. Even if it is a surface also, even for surface also, you will have the similar things. If you closely observe, label style, table style commands. So label style, table styles commands, in any object you will have the same similar kind of style set. If you are representing any when I say label, if you want to see the if like whenever if you wanted to see some this one, just let me change the scale here. One thing you need to observe in civil 3D, it is uh, it is just purely based on the scale. The objects that whatever you see, it is just purely based on the scale that you might be observing it now. Like when I increase it, this the annotation, it is called annotation. The annotation also gets affected. So the what I'm trying to say, when you see in the surface or points or anything, you have those kind of labels, tables, commands. These style sets are very much common. So here it shows you how do you represent the contour. So what are the style set, how should refer, how should it should be shown on the model space. Those sort of things are discussed in the, are shown in the settings. I recommend initially, even though if you don't get into the settings tab, that is very much fine. Once you get into the familiar with the prospector tab and basic um, design flow of the entire software, then you can dig out the settings tab much. And the survey, it is just if you have a very big database of the surveys that it generally use. But mostly for highway price, we can even without using this also we can import the data in many ways. And when you see the last tab, it is a toolbox. It is all about, now you have a design, you have everything, but sometimes what contractors ask you to give it for, they generally ask you to give for the proposed elevations of the road, or proposed elevations of the drainage, or proposed elevation of the pipe network, or curbstone elevations, or any junction reports, or what the camber details. So those are all can be exported from the toolbox tab. So there is a report manager. So here there are different types of reports are there which you can export them, so that it comes under one Excel spreadsheet. You can save them as Excel spreadsheet, and you can share it with your contractors, which can be used for many purposes. So yeah, this is the very much brief about this one, and the prospect and the tool band and this all about. So what I feel, what I recommend, if you are, because as I see in Naushad and Nabil's, like you, even though you are new to civil 3D, but I assume you might be familiar with the cross sectional elements of the civil 3D. I mean, road components and the terminology like superelevation and the camber, and at least those elements, I assume you are familiar with them. If not, you can just let me know, so that at least I can just briefly touch you on that, so that when we get into the actual geometric design tools, it is just not that we are learning only civil 3D, we are just learning with a logic, because there should be a reason to provide a curve. So the curve, the reason behind it is the concept. So yeah, so you can just tell me, you can this is what I thought to discuss with you today. So like if you can open up bit about your geometric concepts, if you are aware, or if you are not aware, like how to 1 to 5 scale, to what extent you know. So based on that, at least I can touch a bit on that in the next class, and then I can start with the actual civil 3D as well. So yeah, that's all from me.